Topic 2.3, solving quadratic equations by factoring and by formula. First of all, I want to compare the difference between a linear equation versus a quadratic equation. Okay, the general form of a linear is this. Okay, it's the idea that the highest power is a 1. So let's say we have a linear equation, 5x minus 2 equals 3. Okay, linears are basically solved by isolation. What we do is we isolate for the variable x, and that gives us our solution. And notice that the linear is the first power and we have only one solution. Now, the general form of a quadratic is this. Okay, this is the general form of a quadratic equation, and where the highest power is 2, and that's what makes it a quadratic. So an example would be 1x squared minus 3x plus 2. Now, the reason why we can't use isolation here is because these two x's cannot be combined, and even if we put the 2 on the other side, there's no way to get a single x. Factoring will not help either. So there is no way of kind of isolating the x's here, so we need another method in order to solve the quadratics. The method that we're going to use is called the factors of 0 property. The factors of 0 means that if you have factors that are multiplying and those factors are set equal to 0, then you can take each one of those factors. If you have this, then you can take each one of the factors and set them individually equal to 0. And that's what we're going to do for the quadratics. We're going to take the quadratics, make sure they're set equal to 0, and then we'll see if we can make these into factors. Each factor that we get can be set equal to 0. Number 1 is a quadratic because the highest power is a 2. I'm going to use the 0 factor. So I want to make sure all this is set equal to 0, so I'm going to move 4x and 5 to the other side, so we'll get additive inverses for those. So we'll have x squared, a negative 4x, additive inverse for this is negative 5, and now it's all set to 0. Once I have it set to 0, then I'll work on getting factors. So trinomials factor into two binomials. Let's have x times x, and we'll factor 5 into 5 times 1. Then the signs need to be different, and we need to get a 4x, negative 4x. So negative, positive, negative, positive. Okay. Once you have your factors set equal to 0, each factor can be set equal to 0. So x minus 5 can be set equal to 0, and x plus 1 can be set equal to 0. And now we can solve by isolation. Here we'll have x equals 5, and here we'll have x equals negative 1 when we add 5 to both sides and we subtract 1 from both sides. Now notice, with the linears you only get one solution. You'll notice that with the quadratics we're now starting to get two solutions that will solve the original problem. And when the highest power will give you the most amount of answers that you'll get. So with quadratics we'll get at most 2 solutions for the equation. Okay, number 2, once again, we want to solve this. This is a quadratic, so we're going to use the factoring method, which means that we want it all set to 0. So these will move to the other side and become additive inverses. 6x squared, this will become a positive 11x, this will become a negative 10. And what's left on that side is 0. So now that it's all set to 0, I want to create factors here. So let's factor this trinomial into two binomials. And 6x squared, let's factor that in 3x times 2x. And for 10, let's factor that in 2 times 5. That'll give us 4x and 15x. And the signs have to be different. If the signs were different to get positive 11x, we would have a negative 4, positive 15. So negative, positive. Okay. Once we have set it equal to 0 and we have factors, each factor can be set equal to 0. So 3x minus 2 is set equal to 0, and 2x plus 5 is set equal to 0. when I isolate x here on this linear, we get 3x equals 2 and x equals 2/3. When we isolate x on this linear, we get 2x equals -5, and eventually x equals -5/2. So we have two solutions, and we knew that because this is a quadratic, we would have at most two solutions. Okay, number 3. Let's see. Number 3, you notice that before we begin that we have fractions. We have a way of eliminating fractions in equations by using the least common denominator. So our denominators are 1, 2, and 4. That means the least common denominator is 4. So I'm going to multiply this entire problem by 4. Distributing 4 gives us 8 here, x squared. 4 divided by 2 is 2 times 5 is 10. And 4 divided by 4 is 1 times -3 is -3. 4 times 0 is 0. So this is our quadratic. And simplify without the fractions, and it's set equal to 0. So let's see if we can get factors. 8x squared, we'll factor that into 4x times 2x. And our 3, let's factor that into 3 times 1. This will give us 6x and 4x. The signs have to be different. Therefore, different signs will not give us a positive 10x. So let's try 1 times 3. This will give us 2x and a 12x. If the signs were different, we could get a 10x by having a -2 and a positive 12. So the combination is negative, positive, negative, positive. All right. It's everything set equal 0. We have factors. Let's set each factor equal to 0. So 4x minus 1 equals 0, and 2x plus 3 set equal to 0. So when we isolate x here, we add 1 to both sides. We get 4x equals 1, and x equals 1/4. Here, we'll subtract 3 from both sides. We get 2x equals -3, and this implies that x equals -3 all over 2. Number 4, which is 1/2 x squared minus 11 over 12x minus 5/6 equals 0. We left to the student to solve. The second method or tool for solving quadratics will be the quadratic formula. The quadratic formula says if your quadratic is in the form of a squared plus bx plus c equals 0, set equals 0, just like the 0 factors, then the solution will be x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times the a term. Okay, this needs to be memorized. This needs to be memorized. Now, when I use the quadratic formula to solve, I use parentheses to keep up with my negatives and positives. Using parentheses is a very good tool to keep up with plugging values into the quadratic formula. Okay. So we want to solve this quadratic by the formula. Again, it has to be set equal to 0. So I'm going to move all these to the other side using additive inverses. So this will be x squared and a -4x and a -5. And now it's all set to 0. Now I have that a is 1, b is -4, and c is -5. We're going to place these into the quadratic formula. So first we need the opposite of b. The opposite of b is positive 4. Then plus or minus the square root, parentheses, b is -4 squared, minus 4 parentheses, a is 1, and c parentheses is -5. And then below we have 2 times parentheses 1. Again, using the parentheses will help clear up the negative issues, because negatives will really spoil the quadratic formula. Alright, now let's go through the order of operation. We'll deal with exponentials first. The exponential here is -4 squared, which is 16. Next is multiplication. -4 times 1 times -5, that's a positive 20. Next multiplication is 2 times 1, which is 2. Okay, now exponents are done, multiplication is done. Now let's do the adding and subtracting. We have 4 plus or minus the square root of 36 all over 2. Now we've done adding. Now we need to simplify this 36. That's a perfect square, so we have 4 plus or minus 6 all over 2. Now this splits into two pieces because of the plus and minus. We have x equals 4 plus 6 over 2, and we have x equals 4 minus 6 all over 2. The 4 plus 6 gives us 10 over 2, and gives us a solution of 5. 4 minus 6 gives us negative 2 all over 2, and the solution of negative 1. Okay. Number 2, we want to solve this using the quadratic formula, so we have to have it set equal to 0, so we're going to move the 10 to the other side. So we're going to have 6x squared plus 11x. The additive inverse of 10 is negative 10, and everything's set equal to 0. Here we have that a is 6, b is 11, and c is negative 10. Therefore, when I put this into the quadratic formula, I have the opposite of b, which is negative 11, plus or minus the square root, b in parentheses squared, minus 4, and then a in parentheses 6, and c in parentheses negative 10. Everything is over 2 times parentheses 6. Alright, let's start simplifying. First, our exponents. We have negative 11 plus or minus the square root of 11 squared is 121. Next, we have a negative 4 times a positive 6 times a negative 10. That's a positive 240. 2 times 6 here is 12. Now, let's combine. Add the units inside. We have negative 11 plus or minus the square root of 361. Correct. All over 12. 361 is a perfect square. It's 19. So this becomes negative 11 plus or minus 19 all over 12. From here, we split up into two parts. X equals negative 11 plus 19 over 12, and x equals negative 11 minus 19 all over 12. Okay. The left side, this simplifies to an 8 over 12, and we can simplify this by 4 on the top and bottom and get 2/3 as a solution. For this one, negative 11, negative 19 gives us a negative 30 all over 12. And we can simplify this by a factor of 6. So we'll get a negative 5 and a 2 for a solution, negative 5 over 2. Number 3, which is 2x squared plus 5/2 x minus 3/4 equals 0. I'll leave this to the student to solve that using the quadratic formula. Number 4 we will solve, and this is in the form that we need. This should be a 6x. Alright, so a is 1, b is 6, c is 3. This means that the opposite of 6 will be negative 6 plus or minus the square root of 6 squared minus 4 times a is 1, c is 3. And that's all over 2 times a, which is 1. From there, we'll begin to simplify by multiplying the 6 times 6, which is 36, and negative 4 times 1 times 3, which is negative 12. All over 2 times 1, which is 2. Okay. This becomes square root of, let's see, 24 all over 2. Now, 24 is not a perfect root, but it has a perfect root in it, which is 4. A perfect square root, should I say. So we're going to make this into 4 times 6. And the 4 can come out as a 2. Square root of 6. Okay. Now, we're going to split this into two pieces. we have x equals negative 6 plus 2 rad 6 all over 6. Oh, sorry, all over 2. And the second solution will be negative 6 minus 2 square root of 6 all over 2. Now, you'll notice that we can simplify with both terms here, so I'm going to split it up into two parts so I can get simplification. Now it's two parts and we have two solutions. A negative 3 plus square root of 6. And over here this will be x equals negative 3 minus square root of 6. Okay, number 5. Number 5, we want to solve this quadratic, and we see that it is set to 0, so we can begin the process of using the quadratic formula. A is 3, B is negative 6, and C is 4. So the opposite of B will be positive 6 plus or minus, parentheses, negative 6 squared, 4, negative 4, parentheses, 3, parentheses, 4 for C, all over 2 times 3. Alright, now let's begin by simplifying by squaring. We'll get 36 here, negative 6 times negative 6. Then a negative 4 times positive 3 times positive 4. That's going to be a negative, let's see, 48. 2 times 3 is 6. Okay. This simplifies to x equals 6 plus or minus the square root of, let's see, 12, negative 12, all over 6. Alright, the negative 12 is not a perfect square, but there's perfect squares in it. So I'm going to break this up into 4 times a negative 1 times a 3. And that's all over 6. Okay. The 4 can be taken out as a 2. The negative 1 can be taken out as an I, and the 3 will remain. So what we'll get is 6 plus or minus 2I and the square root of 3. And that's all over 6. Okay, and we can break this up into two solutions. X equals 6 plus 2I square root of 3 all over 6. And x equals 6 minus 2I square root of 3 all over 6. Number 6 will be left to the student to solve. 1/2 x squared plus 3x minus 9 over 4 equals 0.